Today I am building my own vacuum former to make a lighter body shell for my RC car. My current 3D printed body shell weighs 810 grams, which is way too heavy. That's why I want to switch to a vacuum formed body shell made from PS or PETG. Actually, I am building two. First a small prototype version and then a larger wooden version. I came across a video online of someone who built a small vacuum former using just an oven and a vacuum cleaner. So I decided to start small. Within 24 hours I had made a fully 3D printed vacuum former. And it worked first try. The only issue is that the body shell itself isn't really designed for vacuum forming, because of the chamfered edges at the bottom. I'll fix that later in the video. It wasn't perfect, but it proved that the concept works. And more importantly, that scaling it up would be possible. After that, I started doing more research, and for inspiration I looked at this video. Then I started designing everything in 3D. The design came together pretty quickly, with wooden beams, a base plate, a stainless steel sheet, aluminium tube profiles and some 3D printed mounting parts. The stainless steel plate needed a large number of holes with the correct size and spacing. So I gave AI the right parameters and it calculated the optimal pattern. 360 holes with a spacing of 1 inch and a diameter of 3 mm. I imported that pattern into my CAD software and just like that the full design was complete. After that I ordered all the parts and printed the required components. I started by cutting the wooden beams and aluminium tubes to size, using the grinding stand I made last year. In one of the wooden beams I made an opening for the vacuum cleaner connection. The stainless steel plate was punched and then I removed all the burrs for a clean finish. Once everything was ready, assembly could begin. First I glued 4 wooden beams onto the base plate. While the glue was drying, I used my 3D printed clamps to hold everything in place. Then I mounted the 3D printed parts using short screws. A lot of my screws were actually too long, which caused the wood to split, so in the end I used fewer screws than originally planned. After that I glued the top frame in place, making sure it aligned properly with the bottom frame. These need to match perfectly in the end. Because my grinding stand isn't perfectly square, some of the cuts were slightly angled. Luckily that's easy to fix with sealant. I used bisonwood sealant for this. The only thing is that I forgot that you actually need a caulking gun for that. I could have just bought one, but of course I decided to make one myself. A clamp already looks quite similar to a caulking gun. So I designed a small holder that I could 3D print and slide onto the clamp. With that, I sealed all the seams, the vacuum cleaner connection and the stainless steel plate to the wood. And surprisingly, it worked really well. I might buy a proper one in the future, but for now this does the job. I also printed a small finishing tool to smooth out the sealant. Then everything had to dry for 24 hours. After 24 hours, it was time for the first test. I connected the vacuum cleaner and as you can see, I have vacuum, so the bottom box worked perfectly. Next, I mounted the aluminium profiles and secured them with bolts. Then I slid the frame over the profiles and fixed it in place with a large bolt. After that, I removed the protective film from the stainless steel plate. And with that, the large vacuum former was ready for its first real test. For the test, I used a 1mm thick PS sheet in A2 format. My previous tests were A6 size, so this was a big step up. I cut the sheet to size and attached it to the frame using duct tape. Since polystyrene needs to be heated until it becomes flexible, I also used a half-phase respirator. With an ABEK1 filter on each side and a dust filter. Because the body shell is quite large, too much vacuum would be lost through all the open holes. So I placed a piece of cardboard under the mold to block some of the holes. Then I heated the sheet for about 5 minutes using a heat gun. I turned on the vacuum cleaner and lowered the frame onto the body shell. But unfortunately, the sheet was too large to heat evenly. By the time one section was ready, the rest had already cooled down, and because of that, it didn't work. I tried again with a smaller shape. But that didn't work either. The sheet cools down too quickly, and it also seems like there wasn't enough vacuum. Since the large vacuum former still isn't working optimally, I'm going to give it a third attempt. This time, I'll approach it a bit differently. I'll modify the body shell slightly to eliminate so-called vacuum traps or undercuts. I will also make the bottom of the body shell completely flat, so it has the same effect as blocking some of the holes. And finally, I will use an additional heat source to ensure the sheet heats up more evenly. Still not perfect, but for now I'm putting the large version aside. This small 3D printed vacuum former does work really well though. I've improved and scaled it up a bit, so it's easier for anyone to use. You can download it for free on MakerWorld and print it yourself. And if you don't have PS or PETG sheets, you can even 3D print your own sheets. As you can see here, it actually works surprisingly well. Since the large version isn't quite where I want it yet, I'm wrapping up this video for now. And I'll see you soon in part 2 of this project. Thanks for watching, like, subscribe, and I'll see you in the next video.